Hey everybody, John here, back in week 3. We are talking about quadratic equations, and what we want to do is now we want to graph. We already graphed one that was in standard form, what your book calls standard form, which just required the transformations that we learned back in week 2. Now we want to graph something that's in this form, okay? So the first thing I'm going to do is I want to identify A, B, and C. If you remember back what we did, this was the form of a quadratic that we're in right now. And we have this A value, we have this B value, and we have this C value. And each of these values is going to tell us something about the graph. Now you should have learned about this in a previous course at some point. The fact that you were able to place into this course tells me that you should know about this form of a quadratic, and you should know about A, B, and C, and how to find the vertex. I'm going to go through it very quickly because of that reason. And so just remember that you can always pause and replay if I'm going too fast. So A here is 2, B is 8, C is -10. And I'm most interested in the vertex. And the vertex, the x-coordinate of the vertex, can be found by doing -b over 2a, which in this case is -8 over 2 times 2. And so 2 times 2 is 4, and -8 divided by 4 is -2. So the x-coordinate of the vertex is given by -2. Now to find the y-coordinate of the vertex, I'm going to substitute in -2 in for x in this equation. Or in other words, I'm going to find f of -2. So that's going to be 2 times, so -2 squared is 4 times 2 is 8. Minus 16, so that's -8. And that sort of pattern is always going to happen in this form if you're talking about the vertex. So you're going to get, so here we got 8, and then we're subtracting 16, so we end up with -8. This number, when you plug in the x-coordinate of the vertex, almost is always twice the value of the original. Okay? So we have -8 minus 10 gives me -18. And you'll notice that the graph that I provided here kind of works out perfectly, where -2, -18 is right here. We have the axis of symmetry, which is a vertical line going down through that point. The axis of symmetry is always x equals the x-coordinate of the vertex, so that's x equals -2. Remembering that x equals gives me the equation of a vertical line, because x is always equal to the same value, and y is what's changing. And now from here, since I know that a is equal to 2, and I know where the vertex is, I can now use the same method I was using before. If you don't know about transformations, what you might have done back in high school is then you would find the y-intercept, which is easy to find because you can just read it off of here. It's -10. So I do know this point's on here, and then the mirror image of that point is on here, so that point should also be on here. And then I could also factor this. I can factor out a 2, and that leaves me with x squared plus 4x minus 5. And then I can try to figure out if this factors. What multiplies to -5, but adds to +4, +5, and -1. And so that I know the x-intercepts are -5 and +1. And this is sort of how we graphed in high school, or in a previous algebra class, if you've taken one at the college level. And so this is great. I have 5 points, and that's good. But I can also still use the pattern that I know. I know that normally I go up 1, up 3, up 5, up 7. And I know that this a value is the same value as what would be in this standard form right here. That's this value. So that's my vertical stretch factor. So I'm going to multiply my vertical movements by 2. So I'm going to go up 2, out 1. Then I would normally go up 3, but I'm going to go up 6 instead. So up 6, 1, 2, 3, 4, 5, 6, out 1. Notice I end up at these points that I already found. And then normally I would go up 5, but I have to multiply that by 2. So I'm going to go up 10, out 1. That brings me to these x-intercepts that I found. So you don't have to go through this extra work of finding the y-intercept and the mirror image and factoring. Even if this doesn't factor, I'll be able to find other points that I can use as long as I know where the vertex is and I know what the vertical stretch factor is. So I'm just giving you some options here to graph. Okay, and again, I know that my next move is actually up 14 and then over 1. So I really want to make sure that I'm not flaring out past this line because the over 1 isn't happening until another 10 above this. So it's going to take 10 vertically to get out to this line here. So this happens way up here. Okay. You don't have to go that far, but I'm just letting you know that we should be accurate. All right, so that's graphing in this form, which the book doesn't name, but most people call standard form. Okay? So let's go ahead and find domain and range. Now, this is going to be, domain is going to be easy for a quadratic, and actually any polynomial function. The domain is always all real numbers. Okay? What you want to be aware of is the range, and the range is going to be dependent on where the vertex is and whether I'm opening up or down. If I'm opening up, my range is going to start at the vertex and go up from there. If I'm opening down, my range is going to start at -infinity and go all the way up to the vertex, the y-coordinate of the vertex in both cases here. Okay, so I need to figure out what the y-coordinate of the vertex is, and I need to know whether this function is opening up or down. Well, I see the -2 out in front, which tells me that this opens down. Okay, so I can automatically say that the range is from -infinity to some value, including that value, because I do get to that point. So I'm including that value, that's why I have the square bracket here. Now I need to find out what that value is. So first I need to find the x-coordinate of the vertex. In this quadratic, a is -2, b is 8, and c is -5. So -b over 2a gives me -8 over -4, which is +2. But that's not the value. Okay, now I need to plug this in. That would be where this is horizontally. This is happening at 2. Okay, but now I need to know the value. And I don't even know that the x-axis is here. It could be up here. It could be down here. Whatever the case may be. So I'm going to plug in 2. Notice how I get that pattern again. 2 squared is 4 times -2 is 8. -8, sorry. -8 plus 16. Notice how this is twice as big as this, but the opposite sign. So that gives me 8 minus 5. 8 minus 5 is 3. And so my range goes all the way up to 3 and then stops, including 3. 3 is a value. I just got this value out of my graph, out of my function. So that means I'm including that value. And that's how we find domain and range for a quadratic. If it was opening up, it'd be the same idea, except we would start at the y-coordinate of the vertex and we would go all the way to infinity instead if we were opening up. Okay, so I will catch you in the next video.